Welcome to solverfy.
We can say that the energy of the electron in region 1 would be equal to the kinetic energy of the electron in region 1, and this would simply be equal to 1/2 mv squared. We can solve. This would be 1/2 multiplied by 9.11 times 10 to the negative 31st kilograms multiplied by 1200 meters per second quantity squared, and this is going to be equal to 6.56 times 10 to the negative 25th joules. And this is going to be equal to 4.0995, we can say micro electron volts. We can say the angular wave number in region 1 would be 2 pi over lambda, the wavelength. This would be equal to 2 pi divided by the Planck's constant divided by the momentum. This is equal to 2 pi times mv over Planck's constant. And we can find the angular wave number in region 1 to be 2 pi times the mass of the electron, 9.11 times 10 to the negative 31st kilograms, multiplied by 1200 meters per second. And then this would be divided by the Planck's constant, 6.626 times 10 to the negative 34th joules seconds. And then this is going to be equal to 1.036 times 10 to the 7th. This would be per meter. The transmission coefficient for a barrier of height U sub b and a width L would be T, the transmission coefficient, is going to be equal to e to the negative 2bl. And then we can say that b, the height, would be equal to 8 pi squared times the mass multiplied by U sub b, the potential energy, minus E. This would be divided by h squared, the Planck's coefficient squared. And we can find b to be equal to, this would be 8 pi squared multiplied by 9.11 times 10 to the negative 31st kilograms multiplied by 4.719 micro electron volts minus 4.0995 micro electron volts. And then this would be, we're going to convert 1.6 times 10 to the negative 25th joules rather per micro electron volt. And so micro. And we can then say that this would be all divided by the Planck's constant squared, 6.626 times 10 to the negative 34th joules seconds quantity squared. And we find that B is equaling 4.0298 times 10 to the 6th. And this would be, again, per meter. So we can then say that T, the transmission coefficient, would be the exponential function of negative 2bl, and this would be equaling the exponential function of negative 2 times 4.0298 times 10 to the 6th per meter, and then multiplied by L, so 200 multiplied by L times 200 times negative 9th per meter. And we find that the transmission coefficient T is equaling 0.1995. So the transmitted current I sub T would be equal to the transmission coefficient times the current. This is going to be 0.1995 times 9.0 milliamps. And the transmitted current is going to be equal to 1.795 milliamps. This would be our final answer. That is the end of the solution. Thank you for